motors and generators are all about the relationship between electricity and magnetism. And it was not even known that there was a relationship between the two until the year 1820. And people in the early days of electrical science, all they did was play. Like kids with toys, they played. Just like when you were kids yourself and you got a couple of magnets. Whoa, let's have fun playing with magnets, you know. And by playing with things, they learned about the gentleman by the name of Oersted. Had a class in natural philosophy, which is what they used to call science. And they were goofing around, they were playing around in class. And some of the students were playing with a voltaic pile and a piece of wire. And nearby, there was a compass. And what they noticed is, the students noticed, that when electricity went through the wire from this voltaic pile, can you guys see the needle? Moving around. If you can't, come on up here. The needle started to move. Emphasis on the word move. So right away that showed, my gosh, we know this is electricity. We know that's magnetic. We have now proven there is a relationship between electricity and magnetism. They didn't know what that relationship was, but all of a sudden here what we have is just another example of how people played back then. Here I have a thin piece of magnet wire, and I have two cradles made of copper. I have an invisible magnetic field going from North Pole to South Pole in here. Now, what I've got, if you look at this, is just a simple D cell. And if I connect these two wires to the terminals on the D cell, I'm going to make a direct current flow. It'll flow down the wire here. I have physical contact there, so it will conduct down this wire. And then it'll come back here, complete the circuit at the other terminal of the cell. So what they would do is they would take and set something up like this in their playing, and they would touch that. And do you see the thing moving? Watch the wire bouncing and moving in there. Let me see the jumping and moving there. See it moving? Now here's what's going on there. When electricity is going through that wire with the polarity where you saw it move, the wire was starting to literally jump off the cradle. Well, as soon as it jumps off the cradle, even that much, what happens to the flow of electricity? It breaks the circuit. So there's no more electricity flowing, so it drops. As soon as it drops, guess what? Makes the circuit. So the reason you see it bouncing like that is because it's continuously making and breaking the circuit. Now, again, we're seeing the relationship between magnetism and electricity. Now, by now, I've seen it twice. Tell me what the thing is that relates electricity to magnetism. When I completed the circuit, what did the needle do? Moved. When I connected the circuit here, what did the wire do? It moved. So what is the physical phenomena, which is the connection or the link between electricity and motion? Motion is the connection between electricity and magnetism. Shown again, the relationship between electricity and magnetism is motion. And when we play with this, and this is what they did was play, you start to learn a lot of interesting things. Notice when I go down, the needle goes to the left. When I come up, the needle goes to the right. But watch this. If I flip it the other direction, now when I go down, it goes to the right. When I come up, it goes to the left. Watch this. What if I go real slow? If I go real slow, it doesn't move very far at all. But if I move fast, it moves further. Now somebody would say, okay, well that's just one wire. What if we take this wire and we wrap it into a coil like this? Now what happens when I go through now look, 2 wires, twice as far. Well hell, let's do it again. Let's go 3. Now I got 3 loops. Whoa, now I'm really cooking. And if I do it in terms, you need to learn right away. With the little demonstration I did before, I had a system where I forced electricity into the system and I made a wire move. That phenomena has a name. The name of that phenomena is motor effect. When you force electricity in and you create motion, that's called motor effect. With this demonstration, I am forcing motion in, and I'm creating electricity. The name of this phenomena is generator effect. So if I force electricity in and create motion, that's called what?
Motor.
Motor effect. If I force motion in and create electricity, what's that called?
Generator.
This right here is an extrapolation of these principles built into this little box right here. Inside of this case, there is a permanent magnet with a north pole on one side and a south pole on the other. Inside of here, there is a coil of wire.
Looks
Now-
like an engine starter.
Say what?
Looks like an engine
It's
starter.
actually a DC motor, is what it's sold as. But the point I want to make is that a motor and a generator are both at the same time. I can force electricity into it and it becomes a motor. Or I can force motion into it and it becomes a generator. But they're both at the same time, because think about this. How did I make electricity with that motion? I caused the wire to move through the magnetic field, and now I had electricity moving through the wire, right? Now go right back to the first demonstration. When I had electricity going through the wire, what did the wire do? It moved. And here's what happens. They fight each other. The motor and the generator it's schizophrenic, and it's wanting to be both at the same time, and it's fighting itself internally. And I want to show you how it fights itself. So I need a volunteer. Who's going to volunteer? Sure, come on up. Come on up. And Luke, you may want to turn around to the side over here a little bit. And here's what you're going to do.
Okay.
You are going to, are you right-handed, I hope?
Yes.
That's good. You're going to put your left hand here. You're going to grab the crank. You're going to turn this thing and get it going at a pretty good clip like that, okay? Now, these are, right here, the two wires coming off of there. So go ahead, put your hand to hold it firm and get it cranking. Go pretty quick, pretty quick, pretty quick. Okay, stop. Is that hard? No. How much electricity is flowing right now?
None right
Now
now.
nothing.
None, because, by what kind of circuit?
Open.
Open circuit. Now, if he's turning that, what would be the easiest thing I could do to make electricity flow?
Grab it.
Put the two together. Put the two together.
I don't think I
So
grab
let's try
it.
that. So now, get that thing cranking, go real quick, and I'm going to go. Get it going. Right here I go.
Resistance.
Yeah, go ahead. Yeah. Right, here we go. Here we go. Anybody else want to feel that? Come on up and try it. Somebody else come up and try it. Get her going. Get her going. Ready? Get her going. Get her going. Get her going. See that? So what is going on here? What's going on here is that as soon as electricity starts to flow, it wants to become a motor going back in the other direction that he's cranking it. That's called back torque. What it really is it's the motor effect inside this schizophrenic machine. Now, why is it making electricity? It's only making electricity because he's forcing more torque in this way than what's coming out the other way. So one of you guys that did this already, go ahead and get on the crank again as soon as I get this.
I
No.
did my time.
Well, no, I want one of you that already did it so you get
It's
a
gonna go
relative
easier,
feel.
don't worry.
Yeah, it'll be easier this time. Before I short circuit it.
It's
So
not
go ahead
fun.
and see if you can light the light. Oh, sorry, didn't mean to light it. Now, is that easy or is that...
Considerably harder.
It's considerably harder, but why is it working? It's working because he's forcing more torque into it than the schizophrenic motor aspect wants to push back against. But you can feel the motor in here pushing back against you, right?
Mm-hmm.
That's called back torque in a generator. So if you've ever looked, for you guys in Luke's class, if you've ever seen that ad in the back of Popular Science magazine, free electricity, and you spend a couple of bucks and you get the plans, and it shows a generator and it shows a motor and the shafts are coupled together, and the generator is feeding electricity to the motor and the shaft of the motor is driving the generator, and you take extra electricity off, bull potty. That will not work. It absolutely does not work because of what you just saw, because of a thing called back torque. Now I want to show you one more thing. The relationship between the motor and the generator. Now we're all going to want to swing around this way because I have some meters here. and I want you to be able to see the meters. So, let's see, this is my voltmeter, so I'm going to put that on the 200 volt DC scale. This is my ammeter, I'm going to put that on the 20 amp scale. And I want my plus to go to plus. And I want my plus from here to go to plus. So I'm hooking up my ammeter in series. I'm hooking up my voltmeter in parallel. And so this is going to go here. And this is coming from the negative side of the battery. Now as soon as I hook the battery up to this, what do you think this thing's going to do? It's going to spin, because I'm now going to be forcing electricity in, which now this is going to become more of a motor than a generator. So I hook that up and it's spinning. And those of you that can see the meters, I want you to look. What voltage are we running at? 12.5. And what current are we running at? Notice the polarity. It's a negative about a half an amp. Do you see how it's going up and down? Look why it's going up and down. It's lifting, the handle is fighting and helping. That's why the current's fluctuating a little bit. But now here's what I want you to see. This is the amount of torque that the motor is willing to give, and it's taking electricity out of the battery to do that. Look what happens. Can you see the meter there?
Yeah, I can see it.
Look what happens when I force it to go faster than it wants to go. What happened to the current? It went positive. Now the current's going the other direction. What do you think I'm doing now to the battery? I'm charging the battery now. Why? Because I'm just forcing the thing to go a little faster than it wants to go. I'm forcing more torque in than it wants to give. Now it's a motor. Now it's a generator. Now it's a motor. Now it's a generator. You can see the polarity changing back and forth. As a motor, it's negative, it's taking current out of the battery. As a generator, it's positive, it's forcing electricity back into the generator.
You can actually see the volts.
And imagine, I read online people talking about, you know what, the world's in a pretty tough situation right now. I want to build myself a bicycle generator to run my house. And I think to myself, holy crap, they better be Lance Armstrong or they're not going to make much electricity, because this is tough work. You saw I just lighten up that light bulb. Whew, and I'm a little bit winded already. Any questions on what you just saw? Next week we're talking about wind generators, right? Next week we're talking about wind generators. This will be good for all you guys to hear. When this thing right here is totally disconnected from everything, and I'm just using it as a generator, how hard is it to turn like this? Not hard at all. This is something very critical with a wind generator. So where'd that lamp go? Right now, yep, there's no current flow, so there's no motor effect, so there's no back torque. So now, somebody get on this thing and crank here a little bit and try to light this guy up. Okay, light him up. Now watch what happens when I turn the light off. Keep going, keep going. Did you feel that?
Yeah.
Yeah, it really takes off, doesn't it? What do you think would happen with a wind generator if all of a sudden the wind generator lost its load?
Fly apart.
Flies apart. The son of a gun gets spinning so fast, it just gets trashed. Loses the load, and that son of a buck will take off until it just creams the whole thing. They explode and shatter from all the mechanical force. Notice the little wind generator over on West Campus. Everybody says, how come it's not spinning? Here's why. It's strictly a battery charging a battery, and I do that. It blocks it and keeps it from spinning and destroying itself. That's why it's not spinning over there, because the batteries are full.
So you need to charge.
So we need to take electricity out of the batteries, so then the controller will say, oh, that guy needs juice, hook it back up to the batteries, and then it'll spin again. Does that make sense?